All right, this problem, we have a block at rest on an incline, and I have the coefficient of kinetic friction and static friction here. And first problem says I want to figure out the frictional force acting on the 10 kilogram mass. So let's start first by drawing a free body diagram for that 10 kilogram mass, right? So there's friction pulling that way, there's the normal force up, and there's gravity pointing down, right? So this is normal force, this is Fg. But remember, because this is on an incline, we're going to turn our axis to look like this. So I'm going to split Fg into a cosine and a sine component. So my free body diagram is going to look like this. I've got friction, I've got the normal force, and then I'm going to have mg cosine theta here, and mg sine theta here, right? So remember, the cosine component goes perpendicular to the ramp, and the sine component is the one that goes down the ramp. Okay, so now that I've got a free body diagram, I can get the frictional force. So frictional force is going to be equal to, right, because this thing is at rest. So at rest, that means the net force is going to be 0. Right, so the net force is 0. So that's going to equal the frictional force minus mg sine theta, right? And so if I do that, that means that if 0 equals that, right, because here's my equation, right? So that basically means that FF equals mg sine theta. And I know m, and I know g is 9.8, and I know the angle here, so I can get the frictional force by doing mg sine theta. All right, so second one. What is the largest angle which the incline can have so the mass doesn't slide down the incline? Okay, so now I'm talking about static friction again, but I want the biggest static friction that I can possibly get. So in this case, I'm going to say that the frictional force equals mu times the normal force, right? I can't use that here because remember, static friction, it's a less than or equal thing. So static friction is like a threshold you have to get to. But here I'm saying I want the largest angle that I'll get. And so the maximum I can actually use this equation. So it's mu times normal force. So let's look at our diagram. I know what friction is and I know what normal force is, because if the thing's not accelerating, friction has to equal this one, normal force has to equal this one. So I'm just going to plug in those things to this equation. So friction is mg sine theta equals mu times normal force. Normal force has to equal mg cosine theta. And so now if I combine these, I'm going to get mu. Mu is equal to, I can divide mg cosine theta over, so it's mg sine theta over mg cosine theta. Mg cancels out, so I have mu equals sine theta over cosine theta, and maybe you know, maybe you don't know, sine theta over cosine theta equals tangent theta. Right, so this gives me mu equals the tangent of the angle, right? And I mean, that's great and all, but I want the angle, right? So remember, if the thing that I want in sine, cosine, or tangent is here, I can just take the inverse tangent. So I can flip this equation around. I can do the other thing by saying theta equals the inverse tangent of mu, right? That just switches the things in those two positions. So I can solve for that, just as long as I'm careful to put my coefficient of static friction. Okay, and then for the third one, what's the acceleration of the block down the incline if the angle of the incline is 39 degrees? So now I'm going to a higher angle, so it's actually going to slide, right? So this angle is going to be less than 39. So I'm going higher, right? So now it's sliding. So now when I look at this thing, it's going to accelerate, let me draw it here. It's going to accelerate down the ramp, right? So start with an equation. Net force equals not 0 anymore because it's accelerating this way. It's not accelerating this way, but it is this way. So it's going to equal ma equals big one minus small one. So big one first, small one second. Mg sine theta minus frictional force. All right, so here's my equation. So if MA equals all of this stuff, right, I want acceleration. mg sine theta is here, and I know m, and I know g, and I know sine theta. And frictional force, now because this is kinetic, right, I can say the kinetic frictional force is mu times the normal force, right? I can take this and I can stick this in here. So MA equals mg sine theta minus mu Fn. All right, and what else do I know? Fn, right? From here, I know Fn equals mg cosine theta. So I know that mg cosine theta equals Fn, right? Because these two are still equal to each other. So I'm going to plug mg cosine theta in here. Right? So let's do another substitution. Ma equals mg sine theta minus mu times mg cosine theta. And if you wanted acceleration, right, I could just solve that equation when you plug your stuff in. So you could do it two ways. You could either do all the algebra first and then move mass over and solve, or I could figure out mg cosine theta, plug it in for normal force, and then do coefficient times normal force to give me frictional force, and then I'm back at this first equation. It's the same thing, it's just a matter of how you approach it mathematically.